Tyler McLeod from the, thanks guys. Network engineer out of our Fargo office, here to talk about Aruba Fabric today, specifically more data center type fabric. Let's go ahead and introduce some of my slides here. And then once I'm done with my slides, I don't have a ton of slides, but I just kind of want to set the level set and get some expectations, right? So traditional versus fabric. Traditional networks, we're all familiar with those today. We've been doing it for a long time if you're in the network space. And traditional networks, we usually do something like MLAG, at least in the data center, we'll do something like MLAG. Actually, let's go to the next slide, right? Look, we have two different types of networks here. We have our traditional, we have a fabric type network. And the big difference between the traditional network and fabric is, traditional, like I said, we've been doing that for years. We're doing, VLANs, we'll do MLAG, we'll do spanning tree, ELRP, whatever that is, right? Whatever we're used to. But we have these active passive between the cores. So we have one core that's not routing or sometimes not passing traffic. And then if we have a core failure, we'll swing over to our backup core. And then we're also doing lags, right? Everybody knows what a lag is, link aggregation, okay? In the fabric world, we no longer have lags between what we call the leaf nodes in our spines, right? We have cores and then we have, top of rack switches. And really in our fabric, our leaf nodes are our top of rack, and our switches that we call our core are more of our spines, right? And there's a little bit of a shift, right? Because in the old days, we actually will pass traffic on our core switches. Sometimes people plug stuff directly into the core instead of using a top of rack switch, which is fine. But in the fabric world, we really are not plugging anything nodes into the spine, right? And let's see, where am I going with this? And then instead of doing lags down here, each one of these connections back to the spine, they're active all the time. And all of the spines are routing traffic all of the time. So you get much more high availability. You get a lot faster convergence time during a failover. If we lose a link, we don't have that 2-minute outage, or we don't have that failover time with a fabric versus a traditional network. The other thing is that in a traditional network, as we know with lags, even if we have multiple lags running from a core to a top of rack switch, a lot of times we're not getting even distribution of traffic over those lags. We're 90% weighted towards the active lag. But inside of a fabric, we're doing round robin with equal cost multipath, and there's OSPF and BGP on that underlay, right? But I think the thing that makes probably the fabric network interesting is when you take a look at traditional networks, we're used to making manual changes, right? So if I need to add a VLAN to that legacy network, I need to log into every single switch. In this example, there's 2, 4, 6 plus the 2 at top. That's 8 different switches I have to log into, and I have to make sure that I get my port assignments, my uplinks assigned correctly. If I make a mistake, I could potentially cause a loop, right? Because I have to tell MLAG that that's also part of my core, right? So orchestration efficiency, we gain a lot of that when we switch to a fabric network, because now we have an orchestration software, in this case called Aruba Fabric Composer, and that takes care of all the work for you, reducing human error, okay? So the orchestration efficiency, plus there's also access to API calls. So I can actually, if I'm a programmer or I have automation tools, I can make direct calls into the Aruba Fabric Composer to not only assign VLANs or create VLANs, but there's no human interaction doing that other than either directly working with the Aruba Fabric Composer or writing some type of script or software that interfaces that Fabric Composer. The other big difference in this case, because we're talking about Aruba Fabric, is the integrations with all the different other types of compute out there. So like, for instance, there's Nutanix or it's VMware, okay? We all, I'm sure, in IT for a long time, hear that story like, okay, VMware virtualization team has an application they'd like to deploy. So now they have to add a whole bunch of VLANs, or we have to figure out, if it's not documented already, where everything is plugged in, right? With the Fabric infrastructure, now all of our compute is visible to the Aruba Fabric Composer. It's also visible inside of VMware. So now if I have a systems guy come up to you and say, hey, I'd like to deploy a VM, and it's going to be a database server, maybe it's a web server, now I can go ahead and I can provision that virtual appliance, and I can have VMware auto-populate the VLAN requirements between the Fabric in the virtualization environment. And so that, again, eases the pain, because if I miss an uplink from my virtualization environment and I do a vMotion, or if I'm in Hyper-V and I move an appliance, now I run into an issue where the appliance is running on a host, but the host doesn't have the correct access to the switching or to the routing infrastructure, right? So Aruba Fabric Composer really kind of fixes a lot of those mistakes, common mistakes, and also helps us with a lot of the automation. Traditional data center networks, right? Switches are managed individually. HA configuration is active-passive. Stateless ACLs, right? We've all, I'm sure many of us have played with ACLs. If we have 8 switches to worry about in the previous example, that means I have to go into every one of those switches again. And if I have ACLs on VLANs or specific networks, now I have to manually make sure that those are all correct. But again, if I make a mistake, now if I move an appliance or a virtual server from one host to another, the behavior might be different, and that, that's a bad thing. Let's see. Basically, integrations are managed manually. So if you have integrations out there today, without an orchestration platform, you're doing all the heavy lifting or the hard work yourself. Troubleshooting can be difficult, right? If you didn't design that network and you have to manually log into switches to troubleshoot issues, it could take a long time. And again, with humans programming a traditional network, the chance for error or mistake goes up significantly. And then inconsistent configuration, right? And I already touched on that. Taking a look at Fabric type-based network, switches are managed by AFC or some type of orchestrator. Again, in this case, it happens to be Aruba Networks, Aruba Fabric Composer. HA configuration is active-active. I touched on that already. Equal cost multipath, right? So if I lose a path, I'm using BFD or bidirectional forward detection. I can drop that link really quick and fail over faster, right? Stateful inspection, and I haven't talked about this, support for large policies, right? So in the Aruba Fabric, there is a particular switch called the Aruba OSCX 10K. And inside of that switch, and actually, let's see if I do have one. No, I'm going to go back. I guess I goofed up that slide. Let's see here, let's get back. So inside of the 10K switch, we have a couple of chips. They're called ELBA chips, and what they do is they do stateful east-west inspection. Now, that's layers 1 through 4. It's all the way up to application layer. But a lot of times, what we're looking for is isolation within the data center. So like as an example, let's say you're a large organization, you have security virtual machines that all sit in a virtual network together. Without some type of east-west control or policing or private VLANing, those hosts can talk to each other. And if I don't have firewalls turned on and one of those hosts gets compromised, now all of a sudden that one compromised host can talk to all the other hosts and potentially compromise the rest of that particular network, right? In this example, even in the same VLAN on the VMware hosts, we can do VM to VM firewalling, stateful firewalling. Now, there's other technologies out there that do that today, such as NSXT, but NSXT runs in the hypervisor itself, and there's a lot of overhead and throughput issues with providing the stateful inspection within NSXT. So what happens is we take our computer resources, we connect it to the Aruba Fabric. Once it's connected, now that Fabric has visibility and control into that virtualized environment. And with the Aruba Fabric orchestration software, we have the ability to automatically deploy that solution without having to go into VMware and make potential 12 12, 15, 20 different changes necessary to make it work. It's all automated for us. Let's see here. Yep, integrations are managed by AFC. So again, if you're talking with Nutanix or you're doing VMware, the integrations are controlled by the Aruba Fabric Composer. Troubleshooting is easier with AFC because AFC put all the configuration there, and you don't necessarily have to hop into a command line to troubleshoot an issue in Aruba Fabric, right? I could take a look in that web interface, and I could take a look at routing tables, IP interfaces, VLANs that are out there. And I'll show you in a little bit too with a live demo. They have basically a connection checker that will actually go through all of your switches and say, we put the configuration on them, but if there's a connectivity problem, it'll show you to say, hey, this link from this top of rack switch to this spine is not connecting right, and you can go back and fix it real easily. AFC manages all the configuration. And that's actually a good thing, because if I have a switch that dies in my top rack, or if I have a spine that dies, and I need to very quickly get that service restored, I can do that because AFC contains all the configuration that's getting pushed out to that switch. And so if I have a problem in my data center, I can go and pull that switch. I can put the configuration back on it. I could put the top rack switch back in the rack, and within as little as 45 minutes, I can swap a switch out. From unboxing to putting software on it, to putting configuration on it, getting it back in the data center. Broadcast, multicast traffic is handled better. And it actually is because of the nature of VXLAN, right? And VXLAN is that overlay protocol that we use to get the VLAN traffic distributed through the fabric itself. And the way that really works, right? We all know in a layer 2 domain, if I'm a brand new host and I'm connecting to that layer 2 domain, I need to send out a broadcast to locate things like my gateway or other services I want to talk to. Well, in a fabric type topology, once I send out that initial broadcast to look for other hosts, all of the other nodes within the fabric have that information in their database. So when the next person attaches to the network, getting that broadcast packet, now the local switch is saying, here's the information you're looking for. I'm not going to broadcast through the rest of the network. So it's much more efficient. And the same thing with multicast, okay? So get past this slide. Automation and control, I kind of covered this, right? Here's all the different integrations that we can work with as well, right? Different cloud. And it's not just stateful inspection on the 10K as well. You can do now. You can do some pretty basic load balancing. You can do IPsec termination. So if you're talking about, right, if I have applications that live up in Office 365 or Azure or Google, now instead of having my north-south firewalls terminate those tunnels up to the cloud infrastructure, I can actually have my fabric, my data center fabric, connect directly to the cloud resources. And now I'm cutting out that middleman of the firewall. The firewall is just a pass-through point in that configuration. And again, the big advantage that we get with IPsec termination directly in the fabric is we're getting to use all the hardware acceleration, those Elba chips that are inside of that 10K top rack switch. And we're able to encrypt up to 200 gigabits per second with that IPsec connectivity. So if you're a very high utilizing data center, there's plenty of throughput there. And you can kind of see this is what the 10K looks like. And you can see right in here, right, we've got AFC, and then we have this Pensando icon. And the way it works is we have a couple of virtual appliances, Fabric Composer, which you've heard a lot about already. But then Pensando themselves have their own appliance, and that appliance really manages all the stateful inspection firewall rules that are in the special Elba chips that are inside of the switch. Okay, so it's really a truly software-defined, fabric network. In a sense, we have the orchestration level, and then we have the actual forwarding plane or the data plane delivering. And you can kind of see some examples here. Okay. And then demo time, right? I'm going to cut out of here, and I'm just going to show you, if I can here. I'm going to show you, hopefully show you this in real time. And so this is the Aruba Fabric Composer as it looks, and you can take a look at the dashboard, and you can see I have a very small fabric. And running this stuff in my utility room at home gets to be expensive and hot. So I don't have very many switches in my fabric, but I have at least one 10K, so I can show you guys the east-west stateful inspection. So you can see I've got 3 switches online currently. And if I want to take a look at what that looks like, I can take a look at the network, and you can see I've got my spine up here, and I've got a 10K over here, and then I've got another leaf node here, just a regular CX6300 switch. And this little purple line indicates in my tiny little lab that basically the VXLAN connection is going from one leaf node to another. If I had 4 switches in here, every single switch would have 3 outbound connections to the other ones, right? It's a complete mesh network, okay? And if and it's all dynamically, it sets itself up dynamically with BGP and OSPF as that underlay. With the integration with vCenter, I can actually take a look at what my vCenter hosts are doing, right? So I have a vCenter host, I have a standard vSwitch. In this example, if you scroll all the way down to the bottom, you can see that AFC understands which virtual NIC is coming off of my vCenter and which port it's coming into on my 10K, right? And this is all done through the orchestration software. I didn't create these components. I simply told AFC that I wanted to create a micro-segmented network, and I wanted to be able to do policy enforcement between virtual appliances in the same layer 2 domain in my virtual host. And on top of that, it supports vMotioning. So if I have hosts that are doing VLANing on a distributed vSwitch, and I need to take a host and move it to a different host, the Elba chips are smart enough to be able to keep up with that movement, right? So if I move the policies, all the security policies and everything follows with it, okay? In other solutions, such as NSXT, there's some convergence time when I do a vMotion because that's all software driven. It's not driven in ASIC, right? So what that means to me as an administrator is I have to, that firewall needs to be torn down, and then it needs to be moved. The policies need to be dynamically moved to another host, right? And if it doesn't do it fast enough, then I start dropping traffic. And that's where this solution is different because everything's in hardware. We have extremely high throughput, 800 gigabits of stateful inspection per switch, which is, think about how much you'd have to pay to buy a firewall to do east-west inspection in a data center for 800 gigabits. I don't know, $500,000, right? And the switches are really cheap in comparison. But if I click on here, I can break this out. And now I can see all of the virtual machines that are part of that micro-segmentation. And all of these virtual machines, even though they're in the same layer 2 domain together, they are being inspected and controlled by that 10K, okay? So if this one host at the top wants to talk to the next host, he has to go out to the 10K. The 10K does all the policy inspection enforcement in the chip and then sends the traffic back into the VMware environment. So it's kind of neat to be able to do this, right? Because in the future, if I need to expand this out, I want to add another micro-segmentation network for other applications. Again, I don't have to create any of these components. I simply have to tell AFC that I want them to do this in my vCenter, and I walk through a series of steps in the GUI, and it creates all the components and lays it all out for me. So what I'm going to do is I've got 2 Linux hosts, and you can kind of see them here. I've got Linux A. It's just a regular, and let me log back in. Right, so I've got a Linux A and a Linux B, and they're sitting in that network together right now. And one of these has an IP, they both have IPs in the same network together. One of these is 10.140.0.10, and then the neighboring one is 10.140.0.110, right? So they're in the same network together. Last octet on the first one is 10. Last octet on the other one is 110. So they're in the same network. And if I want to go ahead and try to ping 110, I can do that right now because my policy in the stateful inspection allows that. And remember again, going back to that other diagram, and we'll just switch back here. If I want to talk from Linux A to Linux B, now because of PV landing, the way it works is, and through the automation, I don't talk directly to him in the same layer 2 domain. All my traffic leaves, goes to the top of rack 10K for inspection, and if the packet gets dropped, the packet never makes it back to the other host. But if the policy allows that traffic to go through, the stateful inspection engine, just like any other firewall, will let the traffic through and you'll see the pings work, right? So what I'm going to show you now is switching to the policy and just changing the order of one of the policy rules to deny some traffic. So I've got a really simple policy in here just for demo purposes. I'm just going to go edit those rules. And what you'll see in the rules tab here is it looks very much like a firewall, right? And so I have this allow, 10.40.0.0/24 to and from. So I'm allowing the local subnet to talk to any other endpoint or host in that network. Now, if I take this one rule right here, which blocks communication between those two appliances we're taking a look at, as soon as I hit apply, that policy has already been pushed into production. That's all it took. So if I come back here and I try to do that ping command again, I can't, right? But if I take a look at the other host, remember this is stateful inspection, so it's direction based. So if I come back over here and I want to ping the other host, from this host I'm allowed to ping back to the other host. And that's true stateful inspection in an east-west in the same VLAN with microsegmentation. And you think about, if you're a development shop or you're a security shop and you want to be able to have fine-grained cloud-type security on-prem, the effect with the Pensando integration really gets you there. That's really my demo, and that's really my talk. Are there any questions? And if not, thanks for coming. I don't know if I'm early or late. No, there isn't at this time. And here's the other thing. I will add this as a side comment. People say, well, if I'm doing east-west inspection and I have these nice firewalls, do I replace 10Ks with my north-south firewalls? And the answer is no. You don't get rid of your firewalls. You just let your firewalls that are application and do what they do best, right? Because I'm going to have applications in out of my data center, potentially up to the cloud, or I want application visibility in a DMZ, and east-west traffic's not going to get me that. But in that situation, that DMZ or that application, is probably not going to use that much bandwidth where it's going to be a concern. So I guess what I'm saying is always use your north-south firewalls where they belong. There isn't a direct integration today. There are some products, like Guardicore is a product that works really well with the Aruba fabric that allows you to take a look at your existing traffic and help you automatically build replacement policies for east-west that your firewall's doing center. But that's probably the closest it'll come to, right? Well, right, and so that, right. Well, and so I have a customer right now integrating this in their data center. They have 26 10K switches, okay? And you have to do it in a phased approach. You can't just turn it on, right? You have to really know what type of traffic is going through your environment. You have to take a look at what policies you're enforcing with your north-south firewalls today. There's a lot of care that is taken when migrating policies from a north-south firewall into something like east-west, what we're doing here with 10K. No, unfortunately not. So, like I said, there are, there are tools like Guardicore and some other tools. And by the way, all of this stuff uses REST API. So if you're a REST guy, if you're a Python guy, you know, you could write a script very easily to take any sort of ACL, transform it, and then programmably shoot that configuration up into AFC. There is one other feature I didn't really highlight, and that's dynamic tagging. And so what dynamic tagging allows you to do is you can build a set of policies within AFC, and then depending upon what type of tagging you use in vCenter, so you could say something like, this is a database server, the SSH service, or maybe this is a web server. And as you build out those virtual machines, you could predefine firewall policies east-west inside of your fabric, and then if you have a systems administrator going in and building that appliance, they can check or they can add the service tag that says this is an SSH server, this is a database server, this is a QA DMZ type server, and then without having to work with the network guys at all, those policies are dynamically created and allocated based upon the vCenter tags that you assign to the virtual appliance. So there's some automation in there too. I guess what I could also show you too here in a second, I'll show you the Pensando Service Manager appliance. So this appliance runs in combination, again, with C. So when you program a CX10K switch, it's a CX switch, just like any other CX switch. If you buy the 10K and never use the Elba chips that are built in, you can use it just like any other switch in your data center. But really the beauty is that east-west inspection, and this is the appliance that works with AFC that actually calculates and computes the policy and then pushes the policy into those Pensando chips for inspection. And I can kind of give you guys a little quick overview of that. So there's nothing that you actually come in here unless you're going to do some troubleshooting or if you're going to deploy this manually, because it is possible to not link this up with AFC. You could actually run a 10K top-of-rack switch in a legacy fashion, and you could still use east-west policing. You could still use Python with the REST interface to tell the Pensando what to do. So I actually like that the Pensando Service Manager is decoupled from the Aruba Fabric Composer, because if I want to do some type of third-party manual integration or automation, I can talk directly to this appliance, right? And anything that's provisioned in here, AFC picks up on its side. So if I create a policy in here, I can have the policy pull back into AFC so I can see what's going on inside AFC, which is really powerful. Or I can, in the case of if you're using AFC already and you're running it in a fabric deployment, you can just talk directly to AFC, and then AFC will talk to this appliance for the firewall policy. But if I take a look in here, let's go under System. If I can get my mouse to move, there it goes. If I take a look at my system, I can see I've got one. This is showing me that I have both Elba chips inside of the 10K that I have in my lab. And then if I can actually see what policies are applied to it as well. I think by just clicking on it. Right, so it gives me a lot of statistics. It'll give me some logging. It'll show me how many hits, how many errors, all that kind of stuff. I can take a look directly at the policy. So if I need to do troubleshooting, if I'm concerned that AFC is not communicating to the Pensando Service Manager appliance, I can go in and check, right? So they give you access to this to be able to take a look at your policies and log entries. Absolutely. You can send IP fix data. You can send syslog, whatever your flavor is. You would be using IP fix. IP fix is a superset of NetFlow, SFlow, JFlow, whatever the full flavor is, right? So yeah, you can definitely get. You can pull a lot of data out of this, and especially if you're a more secure shop and you're going to log all the data and capture all that data, you better have a large enough data lake to collect that data and process it. So, but let's see. I was going to show one other thing here. You can see it. I was going to show. Let's take a look at VRF. So if I take a look at the VRF, you can see how many networks that I have that are redirecting, and I'm trying to find any of this under network. Yeah, so under here is, you can see the policy in here. When it pulls up, here's all my policy rules that were written inside AFC that have been synchronized over. And there's hit counters, and so you can see how many hits each policy is taken. So it literally is. AFC is using APIs to basically tell the Pensando service manager what to do with the switches. And then also, I guess I can add this in there too. There is a spot in here, I can't remember where it's at, but there's another spot in here where you can get access to the AFC environment from within inside vCenter. So if you don't want to log into vCenter, you could actually log into, if you don't want to log into AFC, you can log into vCenter and actually have access to AFC from inside vCenter as well. There's a plugin for it. So it's kind of neat because you can, if you're a systems guy / network guy, you wear multiple hats. Now I can do network orchestration and design and building from within vCenter. And I don't have to leave vCenter if I don't want to. Now, I get access to Pensando Service Manager from vCenter, but AFC has already taken care of the heavy lifting to get that work done. So, all right. Anything else? All right. Well, thanks for coming.